Welcome back, class 12th. After the examination, I hope you have given the examination very well. If you remember, we were discussing about the polarization of light. In that topic, I said I'll show you the polarizer film, but again, this is around half a month before discussion. So, to continue the next topic, I'm going to revive the last topic again. We were discussing about the electromagnetic wave, the light wave. The light wave is unpolarized light, means it radiates its energy in all the directions. And you have seen that suppose if light wave is allowed to pass through this hole, this is just an example. So it may pass, but when the same light was allowed to pass through this section or this duct, so the light was not moving out at the other. This was about what? The polarization, but it was just an example. But further, we came to know about the crystal, that is tourmaline crystal, that was in the shape of hexagon, if you remember. And this is the propagation direction, and here is the light source which emits in all the direction. Uniformly. This is produced by suppose any light source. I have written here source, and the source is emitting the light in all directions. The light is transmitted like this. But if you remember, this light source is unpolarized light, means it is emitting in all the directions. But due to this crystal, tourmaline crystal, or you can say polarizer, this will allow only that axis of light which is parallel to this crystal axis. Suppose this crystal has the axis AA dash, so the light will only pass those rays which will be parallel to this axis, means after this it will be like this only. If we are going to rotate this one at any angle, the same way the output, the emergent ray will rotate. Suppose this is the polarizer, so and this is the emergent light. If I am rotating this polarizer, so only this ray will be received at that end. But if you are going to use again one more crystal, or you can say polarizer, if this polarizer is placed with the same axis parallel to the earlier one, suppose this is BB dash, if AA dash is parallel to BB dash, so the same light ray will also emerge out here, will be received same way as it is here. But if we are going to rotate this one, if you remember the last lecture, in that lecture I had told you, if you will rotate this one, not this one, because if you will rotate this one at any angle, at the same angle, the emergent light will be there. But if I am talking about this one, if we will rotate except this parallel, if we will rotate except this parallel one, so at this place no light will be receiving if we are going to rotate this one. I told you that this one is having a different name. This one will be called polarizer. This one will be called, you might be saying that sir, this one is polarizer, so this one will also be named polarizer. No, the first one which is receiving the unpolarized light, unpolarized light, which one receiving the unpolarized light will be known as polarizer. But this light here, this ray, this light is known as polarized light. This one. So if the light is unpolarized, so this crystal will be called polarizer, and after when the light is polarized with some axis, so this one will be having a different name, will be called analyzer. Now why we are saying that this one analyzer? Suppose you don't know, as I said, this is unpolarized light. Suppose you don't know that either this light is polarized or unpolarized. You have to detect that either this is polarized or unpolarized. How to detect? The very simple way. Take one crystal and put in front of the light and rotate it. If the light is unpolarized, so at any angle, if you rotate it at any angle, you will receive the light. If this light is unpolarized, so if you rotate it at any angle, you will receive the light parallel to the axis of the crystal. So this is polarizer, and this is, we have proved what? The light is unpolarized. Second thing, if on rotating the crystal, only at a particular axis you are getting the light outside. It means what? The light before the crystal is polarized light, because it is coming out of the crystal at any particular angle. Suppose at this angle or at this angle. So this means after this, except this axis, the light is not coming out from the crystal, means there is a dark, means the earlier light source was polarized light, like it here. So this one crystal who is analyzing that either this ray is polarized or not polarized, that is why its name is analyzer. Suppose, as I have written here, polarized. Suppose this is not polarized light, this is unpolarized light. So on rotating, what you will get here? There will be light source, there will be ray. Why? Because this is unpolarized, so this one will be called what? Polarizer. But if it is passing the light only at a particular axis, so that is why this is called analyzer. Now as I said that you will, means I will show you the polarizer film. This is the time. Let's bring the polarizer film. So here I am showing you a plastic paper, a sheet of plastic, another sheet of plastic. This is completely transparent, and this one you can say a little bit darker, the blackish. But one of it is polarizer film. How to detect that either this one or this one is a polarized film? What I said, suppose this one is emitting light. This is reflecting light, not emitting light. This is reflecting light. So this is a polarizer film. You can see whatever is on the board very clearly through this. If we rotate this at any angle, so I think you can see everything written, whatever you are is visible is very clear as it is at any angle. Same way here, you can see it is very clear transparent plastic. So same way here. If I am putting back to back this one, so you can see very clear whatever it is visible. On rotating this at any angle, there is no change in the light whatever is reflecting from the board, because one of it is polarizer film and second one is just a transparent plastic. So I think you can detect it very easily. Now I am getting one more. What I said, if I am going to use single polarizer film, so at any angle, if I am rotating this, so you will receive the light. So see this and use this as a polarizer film. I am saying that this is the polarizer film. So I am rotating this at any angle. You will be getting whatever is here at any angle, at every angle, the same uniform light at every angle. But when there are two polarizer films, one is called polarizer, second is called analyzer, at that time the light will be received at any particular angle. So see again, I am using now the two different polarizer film. See, whatever you are watching on the board, there is no change in the intensity of light on rotating this, no change in the intensity of light through this. And see again, I also want to see. So I am placing back to back. So see, whatever is the light is coming out. Same way here also, no change. But as I said, if you will rotate that one, so what will happen? At a particular angle only light will pass. So I'm going to rotate the analyzer. See very clearly, this is nothing but at this time, I don't know you are able to see or not, there is a change in the intensity of light. Now it is completely dark. I'm putting it very closer to you. See, this is completely dark, and now light is passing, completely dark. This is when both the axes of the crystal is parallel. Okay, and this is the situation when they are perpendicular to each other. So completely dark. See, same way here also. If we will rotate this analyzer, so the intensity of light, whatever is being received at this end, will decrease its intensity gradually. When it will be horizontal, completely dark. See again, light is being passed, so gradually decreasing, and at this angle when they are perpendicular, so completely dark. Now you might be thinking that from where I got this. On every screen display there is a polarizer film. How to detect that? Sometimes you see my face a little bit darker and at some angle bright. So what is this? The polarizer film is on the camera also, on the screen also. So that polarizer film changing the intensity of light at particular angle very bright, at a particular angle very dark. You can, I think you have your own experience while taking selfies. At some angle it is darker, at different angle brighter. So that is about the polarization of light. So we have seen the polarized light, unpolarized light, and you have seen the polarizer film too. Now again, what is unpolarized light? Before that, I want to inform you the electromagnetic wave. The light is electromagnetic in nature. Between the electric and the magnetic field, electric field vector is responsible for the vision. So what is unpolarized light? In which the vibrations of electric field vector are occurring symmetrically in all possible directions and perpendicular to the direction of propagation. Now the point is how we will represent the unpolarized light and the polarized light. You will say we have seen, but one more point I just want to show you that you will say straight that is, this one is unpolarized light. Very easy. And you will say straight that this one polarized light. Why I am telling you this? If the polarization, the axis of the light is this way, so you can represent on the blackboard like this. Nothing good, nothing big deal. But if the polarization is in this axis, so how to represent? At this time, the representation is using dots. This representation gives that the polarization of light is perpendicular to the paper. Or again, you can say for this, vibration parallel to the paper, and this one vibration perpendicular to the paper. Now, unpolarized, vibration of electric vector in all possible direction, vibration of electric vector in any particular direction. Now again, one more thing is, you must know about the plane of vibration of polarized light, plane of polarization of polarized light, and the direction of propagation. Let's draw the diagram first. So for this, Suppose this is the direction of propagation, and here this is the polarized light. I know I don't think this is exactly perpendicular, but you have to consider. Now we have to name plane of vibration and plane of polarization. So draw this the parallel to this axis, or you can say parallel to this board. Draw one plane. This is parallel to the board. So this plane is called, I'm writing here, this is called plane of vibration. So if this is the plane of vibration, so which is the plane of polarization? Exactly perpendicular to this light wave is called plane of polarization. It doesn't mean the polarization is not in this direction. The plane of vibration is only. So the perpendicular to this, let's draw, I'm trying to draw. Trying myself best. So I think it is looking perpendicular, or exactly. No. So this is like this one and this one. I'm showing you like this. So this one is plane of vibration, and the second, this one is plane of polarization. I'm writing here. So this is just only to inform you that what is plane of polarization and plane of vibration, that both of them are perpendicular to each other, and this is the direction of propagation of light. The next topic is about Brewster law and many things more. In the next lecture we will discuss that. Till then, thank you.